Okay guys, so this is the week 23 homework answer key video, the week 23. So before I start explaining the questions in week 23 homework, I want to do a very brief review on what we learned in week 23. Okay, it's actually very simple. In week 23, we basically learned two things, okay, two formulas, and that's everything we learned. Okay, so the first formula is called the slope formula. So this is week 23. Okay. So the first thing we learned is called slope formula. What is slope formula? What does it say? So slope formula says if we have 2 points on a straight line, any 2 points, so this is x-axis and this is y-axis, right? And this is our straight line. Let's call this L. So if we have any two points on the straight line, for example, this is 1 point, right? And the coordinates of this point is x1, y1. Okay, and we have another point, any point, as long as the point is on the straight line. So this point, let's call this x2, y2. Okay, so if we know 2 points with their coordinates, we can find the slope of the straight line. The formula is as follows. We use m to represent the slope of the straight line. Okay, so m is equal to y2 minus y1 over x2 minus x1. This formula is one of the most important formulas we need to know, okay, in linear relation. Okay, so please remember this formula. This formula means if we know any 2 points on a straight line, any 2 points, okay, and the coordinates of these 2 points are x1, y1, x2, y2. If we know this information, and then we can find the slope of this straight line. So that's the first formula we learned in week 23. The second formula, okay, is the formula of the distance between 2 points. Distance of 2 points. Okay, let's draw this graph again. So what does this mean? This means if we have, again, if we have a line segment or a straight line, let's just say a straight line. If we have a straight line, again, it's a straight line, right? If we have 2 points, these 2 points, okay, how do we find the length of the line segment between these 2 points? How do we find that? So that's what this formula can help us do. Okay, so if we have a straight line, right, and we have 2 points on the straight line, how do we find the length of this line segment between these 2 points? Okay. So the formula is we call this distance, we can denote the distance with d. So d is equal to x2, okay, so I forgot. So let's call this x1, y1. So we know the coordinates of this point, right? And this point is x2, y2. Okay, so the distance between these 2 points, so this length is equal to x2 minus x1 square plus y2 minus y1 square. And then we put the square root on them. So the distance between these 2 points, let's call this A and B. So the distance of the line segment AB is equal to square root of x2 minus x1 square plus y2 minus y1 square. Okay, and the logic behind this is we basically constructed a right triangle here. Okay, so this distance, let's call this C. BC is equal to y2 minus y1, and AC is equal to x2 minus x1. Okay, and then we can use the Pythagorean theorem to find AB, which is equal to BC squared plus AC squared square root, right? So that's the logic behind it. So the whole week 21, week 22, week 23, the whole week 23 class, we only learned these 2 formulas. Okay, these 2 formulas. Now let's start looking at the questions. Okay, keep these 2 formulas in mind, okay, because they are very, very important. Okay. Okay. Coordinate geometry. Find the slope of each line segment. Find the slope of each line segment. Slope of AB. So let's do AB first. Okay. Remember how to find the slope of a line or line segment? We pick any 2 points on the straight line or the line segment, and then we use a slope formula, right? So for example, we can pick any 2 points. For example, let me pick this point, which is, so this is 0, right? 0, 0. Minus 1, 2, 3, 4, 5, minus 5, that's x coordinate. For y, 1, 2, 3, 4. So this point has the coordinates minus 5, 4. Right. Let me find another point. Let's use A, for example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. So this is minus 9, 2. Okay, so now we have the coordinates of 2 points on the line segment, right? We can use the slope formula to find the slope. So the slope of AB, let me write the slope formula here again. Slope is equal to y2 minus y1 over x2 minus x1. Okay, so slope of AB is equal to 2 minus 4 over minus 9 minus 5. Right, so be careful when you do the calculation. Okay, like pay attention to the minus sign. So this is equal to 2 minus 4, that's minus 2, right? Minus 2. Minus 9 minus 5, that's minus 9 plus 5. Minus 9 plus 5, that's minus 4. So over minus 4. So this is equal to 1/2. Okay, let's try CD. Again, CD, let me use a different color. We pick any 2 points on the line segment, right? So for example, let's pick this point. Okay, so this is 0, 0, right? This is 0, 0. So 1, 2, 3, 1, 2, 3. So this point is 3, 3, right? And let's pick another point. Let's choose D here. 1, 2, 3, 4, 5, and 1, 2. So this is 5, 2. Okay. And slope of CD will be equal to 3 minus 2 over 3 minus 5, right? Y2 minus Y1 over X2 minus X1. So the answer is 1 over 3 minus 5, that's minus 2, right? So that's just equal to minus 1/2. Okay. Let's just do one more. I'm not gonna finish all the questions because, like I said, the steps are the same. Okay, so I don't see the point of solving all the questions because that will make the video like 3 hours. Slope of EF. Okay, EF. Let me use a different color. So EF, we already have a point here, right? 0, 0. We just need to find any other point. Let's use E, because you can pick, let's say, this point or this point or this point. But the problem is you don't know the exact coordinates of those points, right? For example, if you pick this point, theoretically, you can use the coordinates of this point to find the slope of the string of the line segment. But like, we can't read the exact coordinates directly off the graph, right? So let's pick the points that are easy to read. Okay, so we pick E. E, minus 1, minus 2, 1, 2, 3. So this is minus 2, 3. Okay, so we have 2 points already, right? So EF will be, slope of EF will be 3 minus 0 over minus 2 minus 0, minus 0. Minus 2 minus 0. So the answer will be minus 3 over 2. Okay, so this is how we find the slope of a straight line or a line segment. Okay, we pick 2 points on the straight line or the line segment, and we use the slope formula. So this is slope formula. Okay, let's look at question number 2. Determine the slope of the line passing through each pair of points. State the line sloping upward to the right, sloping upward to the left, parallel to the y-axis or parallel to the x-axis. Okay, so under what circumstance does a straight line slope upward to the right? If a straight line slopes upward to the right, that means the slope must be greater than 0. Okay, so if the slope of a straight line is greater than 0, then the straight line is sloping upward to the right. Okay, if the straight line, if the slope is smaller than 0, then this straight line slopes upward to the left. Okay, so this is the first case, this is the second case. Okay, if the slope is equal to 0, if the slope of a straight line is equal to 0, then this straight line must be horizontal. We analyzed this in last week's homework, right? So if the straight line, if the slope of the straight line is equal to 0, then this straight line must be horizontal. The last case is if the slope of the straight line is not defined, is undefined, then the straight line must be a vertical straight line. Okay, so there are 4 different cases. Let's look at the questions. I will solve all the parts here. So I will do it quick. So A, there are 2 points, right? How do we find slope using 2 points? We literally use the slope formula only, right? We just need to plug all the points, like all the coordinates in the slope formula, and then we're done, right? So slope formula, again, let me write this. M is equal to y2 minus y1 over x2 minus x1, okay? So for A, part A, what is the slope? Slope is equal to 6 over 4 over 5. Sorry, 6 minus 4 over 5 minus 3. So that's 2 over 2, which is equal to 1. 1 is greater than 0. Okay, so it is the first case, which means the line is upward to the right. Okay, so the slope of part A is equal to 6 minus 4 over 5 minus 3, which is equal to 2 over 2, which is 1. 1 is greater than 0. So it corresponds to the first case, right? When the slope is greater than 0, the straight line is upward to the right. So it's upward to the right. Okay. Part B. C, 0, 1, D, minus 2, 5. Okay, so the slope is equal to 5 minus 1 over minus 2 over minus 2 minus 0. 5 minus 1 over minus 2 minus 0. This is equal to 4 over minus 2, which is equal to minus 2. And minus 2 is smaller than 0. So this is the second case. When the slope is smaller than 0, that means the straight line is upward to the left, or you can say downward to the right, right? Upward to the left or downward to the right, doesn't really matter, as long as you know like what we're talking about here, right? So this is the straight line, okay? Part C, slope is equal to 2 minus 1 over 3 minus 8, right? 2 minus 1, that's 3. 3 minus 8, that's minus 5. So this is smaller than 0. So this is, again, the second case over here, right? Second case. So this straight line is also upward to the left. Okay. Let's do D. Slope is equal to 7 minus 6 over 9 minus 2. So this is equal to 7 minus 6, that's 7 plus 6, which is 13, right? 9 minus 2, that's 9 plus 2, which is 11. So this is greater than 0. So the line is upward to the right. Okay. So for E and F, there isn't much. It's not that different for part E and F. So I'll leave those two to you. Okay, you just like plug all the numbers in the slope formula. And if the slope is greater than 0, then it's upward to the right. Otherwise, it's upward to the left. Okay. Oh, okay. So there's no question. None of these parts actually showed us these two cases, but it's okay. Like we just need to know that these two cases also exist. Okay, so if the slope of a straight line is equal to 0, then the straight line must be horizontal. If the slope of a straight line is undefined, then it must be a vertical straight line. Okay. Question number 3. 2 points and the slope of a straight line passing through the 2 points are given. Find the unknown. Okay. 2 points and the slope of a straight line passing through the 2 points are given. Find the unknown. So part A, the given information is 2 points, right? A, A9, and B, A4. So this 8 here, this is unknown, right? We don't know this. We don't know what this number is. This is the unknown. The slope of AB is equal to 3. Find A. So we have 2 points. We have a slope. What should we do? We use the slope formula. The slope is given in this question. This is 3, right? And we know the slope is equal to y2 minus y1 over x2 minus x1. So this is equal to 4 minus 9 over a minus 8, right? So now we have this equation. How do we find this? We multiply a minus 8 on both sides of the equation. So the left side becomes 3 times a minus 8. The right side becomes 4 minus 9 over a minus 8 times a minus 8, right? And a minus 8 and a minus 8 cancel out. So 3a minus 24 is equal to 4 minus 9, which is minus 5. Minus 5, right? And 3a is equal to 24 minus 5, it's 19, right? So here a is equal to 19 over 3. Okay. Let me double check the answer. The answer is right. I checked the answer because it's been like a pretty long time since I did the homework, so I don't really remember the answer. I just want to make sure there's no mistake. Okay, let's do part B. Given 2 points, right, C and D, the coordinates of C are 0, 1, and the coordinates of D are minus 2b, and slope of CD is equal to minus 3. See, same pattern, okay, same pattern. The m is given, which is minus 3, and we know the slope formula, right? M, the slope is equal to y1 minus what y2 minus y1 over x2 minus x1, right? So this gives us minus 3 is equal to b minus 1 over minus 2, right? So we multiply minus 2 on both sides of the equation. The left side becomes minus 3 times minus 2, which is positive 6, right? And on the right side of the equation, minus 2 on the denominator and the minus 2 cancel out, right? So b minus 1 is left, b minus 1. And then we add 1 on both sides of the equation. The left side would become 6 plus 1, right? And that's 7. And the right side will be b. So b is equal to 7. Okay. C, given 2 points, slope of EF is 0. Okay, so now we see slope of a straight line is equal to 0. We don't know what the straight line is, but we know the straight line must be horizontal. It must be a horizontal straight line, okay? And actually, if we know that this straight line is horizontal, then we don't even need to use the formula, because a horizontal straight line, all the points on a horizontal straight line have the same y value. So if this value is 5, then C must be 5 as well. So if you are familiar with, like if you can connect all the stuff that you learned, then this question would be super easy, right? We know that a horizontal straight line, all the points on the straight line. So let me draw this. So this is y, right? This is x. And for example, this is the horizontal straight line, right? Because slope is 0, it has to be a horizontal straight line. So all the points on the horizontal straight line have the same y value, right? The same y value, which is this value, right? And all the points have different x values. So we know that f is equal to 5. Then we know that c, sorry, not f. We know that the point f has the y value of 5. Then we know that the y value of e has to be 5 as well. So c has to be 5. Okay, so this is a shortcut for you if you know the materials like super well. Okay, but how do we solve this using the traditional way? Okay, so m is equal to 5 minus c over 7 minus 1. And we know that this is equal to 0, right? Because the slope is equal to 0. Then 5 minus c is equal to 6 times 0, which is equal to 0, right? So c is equal to 5, right? So this verified my solution over here. Okay, so c is equal to 5. Okay, now let's look at part D. Given 2 points, slope of the line segment is 5. Okay, so all the questions are the same pattern. Okay, so let's do this again. So m, the slope is equal to 5, which is equal to minus 7 minus d over minus 9 minus 2, right? So this means 5 is equal to minus 7 minus d over minus 9 minus 2. That's minus 11, right? So this gives us minus 55 is equal to minus 7 minus d. And this gives us d is equal to 55 minus 7, which is equal to 48. Okay, so I skipped some like the basic operations of equation, because I think by this point we should at least be comfortable enough to do the what is it, like these operations, right? So the answer D is equal to 48. Okay. So that's question 3. Okay. Okay, now let's look at question 4. Okay, question 4 says calculate the length of each line segment. Okay, so everything that we learned in this week, there isn't, how do you say that? Everything's pretty standard. Okay, everything has a very clear framework. Okay, so all the questions have like very clear steps to solve them. Okay, so here, question 4. This question deals with the length of line segment. Okay, and what's the formula? The formula D is equal to square root of x1, it doesn't matter, x2 minus x1 squared plus y2 minus y1 squared. Okay, and so this is the formula of the length of the line segment between 2 points if the coordinates of these 2 points are given. Okay. Yeah. So let's try to apply this formula to these particular points. Okay. So for part A, A 7.3, B 11.6. So AB is equal to 11 minus 7 squared plus 3 minus 6, 6 minus 3 squared, okay, and then square root, right? That's the formula. Let me move this formula so we can always look at this. Let's keep it here, okay? 11 minus 7, that's 4, right? 4 squared, that's 16. 6 minus 3, that's 3. 3 squared, that's 9, right? And square root. 16 plus 9, that's 25. 25 square root of 25 is equal to 5. Okay, so that's AB. Part B, CD, C 310, D 15, 5. So CD is square root of x2 minus x1, 15 minus 3 squared plus y2 minus y1 squared, 5 minus 10 squared. Okay, and then we close this. 15 minus 3 squared, that's 12 squared, right? 12 squared is 144. Okay, these common, how do I say that, perfect square, I mean, you don't have to remember them, but like it'll be helpful if you remember, like, for example, 11 squared is 121, 12 squared is 144, right? 13 squared is 169, 15 squared is 225, etc., etc. Okay. 5 minus 10, that's minus 5, right? Minus 5 squared, that's just 25. 25. Okay. And 144 plus 25, that's 169, right? And remember, I said 13 squared is 169. So 169, square root of 169 is equal to 13. Okay, so that's part B. So what does 13 mean? 13 means the line segment, sorry, the length of the line segment between point C and point D is equal to 13. Okay. Part C. I'm going to do 2 more questions and then I'll go to the next question. Okay. Question C. A0. So E80, F06. Okay. So EF is equal to y2 minus y1, 6 minus 0 square plus x2 minus x1, 0 minus 8 square. So this is equal to 6 minus 0 is 6. 6 squared, that's 36. Okay. 0 minus 8, that's minus 8. Minus 8 squared, that's 64. 36 plus 64, that's 100. Square root of 100 is this is just 10. Okay, this is just 10. Let me do one more example. G00H minus 12, 9. So GH is equal to y2 minus y1, 9 minus 0 square plus x2 minus x1 minus 12, minus 0 square. Okay. So this is equal to 9 minus 0, that's 9, right? 9 squared, that's 81. Plus 12 minus 0, that's minus 12. Minus 12 squared, that's 144. Right? 144. Okay. So 144 plus 81, that's 225. So square root of 225. And remember what I said, 15 square is 225, right? So square root of 225 is equal to 15. All right. So like I said, I don't know whether like your school or your math teacher asks you to remember the perfect squares. I find it very helpful, okay, because like after 10, we know 10 square is 100, right? And after that, I remember most of the perfect squares. So I know that 11 square is 121, right? 12 square is 144, right? 13 square is 169. 14 square is, I forgot, 156, I think. No, it can be. Anyway, I don't remember 14 square. And 15 square is 225, etc. So these common perfect squares are very useful when you solve these questions. Okay, so I mean, if you have time, it's a good idea to remember some of the perfect squares. Okay. Let me find 14 square. What's 14 square? Oh, 196. Sorry, not 156. 196. Okay. Okay, so for this question, there are 4 more like parts, okay, but I'm not going to solve these 4 because, you know, like it doesn't make sense for me to solve all the questions, even if they have the same steps, okay, that will take too much time, okay, so that's question 4. Question 5, find the parameter of triangle ABC correct to 1 decimal place if the coordinates of the vertices are A, B, and C. Okay, so A minus 3 minus 4, B minus 5, 5 minus 2, and C 1, 7. Okay, so we need to find AB, BC, and AC. And we know that the perimeter of a triangle is just the sum of the lengths of the 3 sides. Okay, so basically it's like the question looks fancy, but the main idea of the question is still the distance formula, right? Okay. So on the surface, we need to find the parameter or whatever, like something that sounds fancy. But after all, we still need to use the distance formula, right? So AB, again, let me write this. So distance is equal to x2 minus x1 square plus y2 minus y1 square root. Okay. So AB. So here, whether you do y2 minus y1 first or x2 minus x1 first, it doesn't matter, right? Because it's plus here. So if you switch these two, the result is the same. Okay. I personally prefer to do y first. That's just my habit. That's just my habit. So AB is equal to square root of minus 2 minus 4 square plus 5 minus 3 square. Okay, so this is equal to minus 2 minus 4. That's 4 minus 2. 2 square is 4, right? Okay, let me write the steps. So this is equal to minus 2 minus 4 is equal to minus 2 plus 4. Minus 2 plus 4 square, okay? Plus 5 minus 3, that's 5 plus 3. 5 plus 3 square. Okay. And this is equal to minus 2 plus 4, that's 2, right? 2 squared, that's 4. Plus 5 plus 3, that's 8. 8 squared, that's 64, right? So this is equal to 68, square root of 68. And if you use the calculator, you will find a number, okay? But because I don't have a calculator with me right now, I'm just going to leave it at 68 square, sorry, square root of 68, okay? BC. BC is equal to square root of BC, 7 minus 2 squared plus 1 minus 5 squared, right? And this is equal to 7 minus 2, that's 7 plus 2. 7 plus 2 is 9, 9 squared is 81. So that's 81 plus 1 minus 5, that's 4. Sorry, 1 minus 5, that's minus 4. Minus 4 squared, that's 16, right? So the answer, so the length of BC is equal to 81 plus 16, that's 97, square root of 97. Again, if you have your calculator with you, you can find a number. Okay, you can find a decimal, but I don't have a calculator with me right now, so I'm just going to leave it as square root of 97. Okay, and AC is equal to square root of 7 minus 4, right? Square plus 1 minus 3 square. So all these three sides of the triangle, okay, use the distance formula, this one, to find the distance between the points, right? So 7 minus 4, that's 7 plus 4. 7 plus 4 is 11. 11 squared, that's 121. 121 plus 1 minus 3, that's 1 plus 3, which is equal to 4. 4 squared is 16. 16. So the answer is 121 plus 16, which is 137. Square root of 137. Okay, you can find the number. Okay, so what are the lengths of these three sides? My square root of 68, square root of 97, square root of 137. So the perimeter of the triangle is equal to square root of 68 plus square root of 97 plus square root of 137. Okay, so that's the question 5. Question 6. The points A, B, and C are the vertices of a triangle. Find AB, BC, and AC. Show that AB squared plus AC squared is equal to BC squared. Okay, see, like it has a fancy like question. It looks like a fancy question, but the real thing that the question is trying to test you is still the distance formula, right? So it doesn't matter how the question changes, you need to know the real thing that the question is trying to test you. Okay, don't get intimidated by like show this or show that. Like don't get scared or don't panic. Right? So AB, BC, AC show that AB squared plus AC squared is equal to BC squared. Okay, so AB, what's the distance? Distance is equal to y2 minus y1 square plus x2 minus x1 square under the square root, right? So AB is equal to square root of, I'm not going to write all the steps, okay, because I've repeated this so many times. So 3 minus 6, 3 minus 6, that's minus 3. Minus 3 squared, that's 9. Okay, plus minus 4 minus 1, that's minus 5. Minus 5 squared, that's 25. Okay, square root. Okay, so 9 plus 25, that's 34. So AB is equal to square root of 34. Okay. BC, again, I'm not going to write all the steps because I think I've written enough. BC is equal to 1 minus 3, which is minus 2. Minus 2 squared, that's 4, right? Plus 4 minus minus 4, which is 8. 8 squared, is 64. So 64. So this is equal to square root of 68, right? AC. AC is equal to square root of 1 minus 6, which is minus 5. Minus 5 squared, that's 25, right? And 4 minus 1, that's 3. 3 squared, that's 9. So 25 plus 9. So AC is equal to square root of 34. Okay, so now we find AB squared plus AC squared. AB squared is equal to square root of 34 squared. AC squared is equal to square root of 34 squared. Okay, so this is equal to 34 plus 34, which is equal to 68. BC squared. BC squared is equal to square root of 68 squared, which is equal to 68. So now we can show that AB squared plus AC squared is equal to BC squared. Okay, the question didn't ask this, but like, what does this show us? What does this tell us? This means triangle ABC is a right triangle. Oh, actually, the question asked us is in part B. Is triangle ABC a right angled triangle? Yes. Triangle ABC is a right triangle. How do we know that? Because of this Pythagorean theorem. Pythagorean theorem. Okay, so yes, triangle ABC is a right angle triangle. Okay, that's question number 6. 7, shape A at point A 120, 160 was on fire and sent a signal to call for help. Shape B at point B 20, 40 and shape C at point C 140, 20 received the signal. Which shape is closer to help the shape on fire? So we have 3 points now, right? We have point A. So this shape is on fire. And we have 2, 1 second, please. So we have point A. Point A, this shape is on fire, right? And there are 2 ships that can come and help. Shape B. Shape B is at the point 20, 40. And shape C is on the point, is at the point 140, 20. Okay. So what is this question really trying to test us? What are we really trying to do here? We're trying to find the distance between AC and the distance between AB and see which one is closer, which one's shorter, right? If AB is shorter, then shape B should be coming to help shape A, right? If AC is shorter, then shape C should come to shape A to help, right? So the question is really, what the question is really testing us is still the formula of the distance of 2 points. Okay? So we have AB and AC. Distance of AB, again, let me remind you. The distance is equal to y2 minus y1 square plus x2 minus x1 square. And we put all these under the square root. Okay, so distance of AB is equal to square root 160, or it's what AB, yeah. So 160 minus 40, that's 120 square, right? Plus 120 minus 20, that's 100. 100 square and square root. Okay, so this, I need to use my calculator. Okay, so just give me 1 second. Let me find my calculator. Okay. So 120 square, that's 14400. Okay, 14,400. Plus 100 square, that's just 10,000, right? And then we find the square root of this. So this is the square root of 24400. Let me find this. 24400. So this is equal to 156.2. Okay, 156.2. Yeah. So that's distance of AB. What about distance of AC? Distance of AC is equal to 120 minus 140. That's minus 20. Minus 20 square. Minus 20 square. Plus 160 over, sorry, 160 minus 20. That's 140. 140 square. Right? And then square root. So this is equal to minus 20 square. That's 400. Right? 400. And 140 square. That should be 196. 0, 0. So 19,600. And then square root. Okay, so this is equal to 20,000. Right? 20,000. 20,000, square root of 20,000 is equal to 141.4. Okay, so obviously AC is shorter than AB, which means shape C is closer to the shape on fire. Right? So here, actually, if you don't have a calculator, you don't really need to find these two numbers. Why? Because for the square root, okay, if we want to compare two square roots, we can compare the number under the square root. Because the square root, you can see this as a function, right? So whatever the square root gives us, like it's the same. So if this number is bigger than this number, then the square root of this number is definitely bigger than square root of this number. So we know that 24,400 is bigger than 20,000. So square root of 24,400 is definitely bigger than square root of 20,000. Okay, so even if we don't have a calculator, even if we don't know these two numbers, we should know that this number is bigger than this number. Okay, so AC is shorter than AB, which means C is closer to the shape on fire. Okay. Now let's look at the last question, question 8. The vertices of, I don't even know the word, give me 1 sec. Okay, so the word is pronounced as rhombus. Okay, rhombus. So I just Googled this. In plain Euclidean geometry, a rhombus is a quadrilateral whose 4 sides all have the same length. Another name is equilateral quadrilateral, since equilateral means that all of its sides are equal in length. Okay, okay, now I know what this means. So a rhombus is basically just a quadrilateral. Okay, what's a quadrilateral? It's a 4, okay, so it's like this. Okay. Okay, so a rhombus looks like this, where these two sides are parallel. These two sides are parallel, right? So if only these two sides and these two sides are parallel, then it's just a quadrilateral, right? But if these 4 sides are all equal in length, that's what makes a quadrilateral a rhombus. Okay, so a rhombus is a quadrilateral where all 4 sides are equal. Okay, so let me just highlight this. Okay, a rhombus is a quadrilateral where all 4 sides are equal. Okay, so yeah, I've never seen this word in my entire life. Okay, so part A. Okay, so the vertices of the rhombus are -3, 1, 0, -3, 5, -3, and 2, 1. So those are 4 vertices of this rhombus. Okay. Part A is as find the slope of the sides PQ and SR. Show that the sides are parallel. So this, I don't know if you guys do remember this. Okay. How do we determine whether 2 straight lines or 2 line segments are parallel? Using slope? Okay. Let me write it here. So if the slope of 2, let's just say n, of n straight lines are equal, then these straight lines are parallel. This is a very, 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 very important conclusion that we need to remember, okay? Because now we need to use this conclusion now, okay? But this conclusion plays a lot bigger role in the future when you study linear algebra. So when you study like vectors and stuff, so you have to remember this. If the slope of n straight lines are equal, if the slopes, let me make this correct. If the slopes of n straight lines are equal, then these straight lines are parallel. Okay? So how do we show that these sides are parallel? How do we show that PQ and SR are parallel? We find the slope of PQ and we find the slope of SR. If the slope of PQ and slope of SR are equal, then we can show that these two sides are parallel. Slope of PQ is equal to y2 minus y1 over x2 minus x1, right? PQ, so that's minus 3 minus 1 over 0 minus 3. Okay, and this is equal to minus 1, minus 3 minus 1, that's minus 4. Minus 4 over minus 1, sorry, 0 minus minus 3, that's positive 3. So that's just minus 4 over 3. Right? Slope of SR, that's equal to 1 over, sorry, 1 minus minus 3 over 2 minus 5, right? 1 minus minus 3, that's 1 plus 3, which is 4, over 2 minus 5, that's minus 3. So this is minus 4 over 3. Okay, so minus 4 over 3, minus 4 over 3. The slope of PQ and the slope of SR are equal. So this tells us that PQ is parallel to SR. Okay, so this symbol over here, this shows, this means parallel. Okay. Part B, find the slope of the diagonals PR and SQ. Show that the diagonals of the rhombus are perpendicular. How do we show that two line segments or two straight lines are perpendicular using slopes? Okay. Here is another conclusion that you need to remember. Okay. So let's say we have two straight lines, L1 and L2. Okay, and the slope of L1 is M1. Slope of L2 is M2. Okay, so if M1 times M2 is equal to minus 1, then L1 and L2 are perpendicular. Okay, so this symbol means perpendicular. Okay, let me repeat this. So if we have two straight lines, L1 and L2, L1 has the slope M1, L2 has the slope M2. If M1 times M2 is equal to minus 1, then this means the straight line L1 and straight line L2 are perpendicular. So back to this question, how do we show that PR and SQ are perpendicular? We find the slope of PR and we find the slope of SQ. If the slope of PR times the slope of SQ is equal to minus 1, then we can show that these two straight lines or these two line segments are perpendicular. Okay, so slope of PR is equal to minus 3 minus 1 over 5 minus 3, right? Y2 minus Y1 over X2 minus X1. So this is equal to minus 4 over 8, which is minus 1/2. Okay, so slope of PR is equal to minus 1/2. Okay. What about slope of SQ? So the slope of SQ is equal to 1 minus 3 over 2 minus 0, which is equal to 4. 1 minus 3, that's 1 plus 3, right? Which is 4. 4 over 2, which is 2. Okay, so we have the slope of PR is equal to minus 1/2, and slope of SQ is equal to 2. Okay, so slope of PR 1/2 times slope of SQ, 2. This is equal to -1. And this tells us that PR and SQ are perpendicular. Okay, this is how we show that PR and SQ are perpendicular. Okay, C, show that a rhombus is a quadrilateral with all sides equal. So part A and part B. So this is a very good question actually, because like different parts tested as different formulas, right? So for part A and part B, we had to use the slope formula to find all the slopes, where for part C, we need to use the distance formula to find the distance for these two line segments. Okay, I'm going to do 2 of the 4, okay, because we've done a lot of similar questions, okay? So PQ, how do we find PQ? Let me write this formula again for you. B is equal to y2 minus y1 square plus x2 minus x1 square. And everything, okay, everything here needs to be in the square root, okay? So PQ, what is PQ? PQ is equal to square root of -3 minus 1, which is -4. -4 square, that's 16, right? And 0 minus -3, that's 3. 3 square, which is 9. So this is -25, which is 5. Square root of square root of 25, that's just 5, right? QR, square root of -3 minus -3, that's 0. 0 square is just 0, right? And 5 minus 0, that's 5. 5 square, that's 25. So this is just equal to square root of 25, which is 5. Actually, let me do the other two as well. So RS is equal to square root of 1 minus -3, that's 4. 4 squared is 16, right? And plus 2 minus 5, that's -3, -3 squared, that's 9. So 16 plus 9 is 25. Square root of 25 is 5, right? SP is equal to 1 minus 1, that's 0. Square root of 1 minus 1, 0. 0 squared, that's just 0, right? Plus 2 minus -3, that's 2 plus 3, which is 5. 5 squared, that's 25. So 25. So it's also square root of 25, which is 5. So we proved that these 4 sides of the rhombus are equal. Okay, they're both equal to 5. Okay, so that's the last question for week 23 homework. Okay, so yeah, like I said, week 23 homework is not technically difficult, right? Because as we can see, basically all the questions are pretty much based off the 2 formulas that we found. Sorry, 2 formulas that we learned, right? One is the here. One is the slope formula, right? And the other is the distance formula between 2 points, right? So if you remember these 2 formulas correctly, you can do most of the questions, okay? But you also need to remember the 2 conclusions that we learned here, okay? So how do we use the slope of straight lines to prove that they are parallel or perpendicular? Okay, if the slopes are equal, if the slopes are equal, then the straight lines are parallel, okay? If the product of two slopes is equal to -1, then that means the two straight lines must be perpendicular, okay? Okay, so this is week 23 homework, okay? You can expect the homework answer key video for week 24 and week 25 in 1 to 2 days, okay?